In my game you play a spaceship tasked with defending a random planet. This is the game loop. First you defeat enemies, then you earn score points, then you defeat waves of enemies, then if the planet runs out of health, you lose, then you restart. This is how the waves of enemies work. For each wave there are a set number of enemies to defeat. Once you do that, more will spawn and the wave number will increase. A small bit of the planet's health is restored every time you defeat a wave. The number of enemies in each wave increases every time you clear a wave. My game uses game states to select the logic executed. The menu game state shows the title screen before the gameplay begins, and to start playing you need to press any key. Once the playing game state begins, the background music is started and the game's logic is handled. The game over game state stops the game, the music, and shows the restart button. This checks the planet's health every frame. If it reaches 0, the planet is destroyed. These are all of the JavaScript files for the project. I split the functionality this way to make the program easier to read, as well as having clear groups of logic. The audio manager handles the loading of sounds and music as well as playing them. The audio clips have to be initialized before use. In the enemy manager, the enemies are spawned around the planet. Firstly, a random number between -1 and 1 is picked. This number then marks a point somewhere on the y-axis. Take this value and then imagine it's a latitude ring around the planet. Then rotate around the ring by a random angle, which is called theta. Then find the exact point on the ring, and then extend the point out using the offset and then place the enemy there. Finally attach this to the planet and repeat for as many enemies as you need. The enemy manager also cleans up defeated enemies. Each defeated enemy is removed from the planet's mesh and then taken out of the array of enemies. To give the illusion of player movement, it's the planet that's rotated beneath the player. I use an enumerator for smooth movement, which stores the true and false values of different inputs. The key up and key down handlers just check for whether there is a key pressed or released. A switch statement is used to control which directions are held down. These values are then read by the movement script. To allow for mobile controls, I made HTML button elements which are binded to different movement options. Here's some mobile gameplay. This clip shows the responsiveness of the website and the game window. If the window is small enough, the mobile controls appear. Everything is updated in the update function within the game manager, things like movement, health, combat, and UI. When the spawn enemies function is called, it checks whether more enemies are needed, and if so, spawns more. The UI elements get updated each frame. This includes the planet health bar, the current score, the waves left, and the amount of enemies remaining. It does this using the getElementById to get the HTML element within each specific ID. The planet's health bar changes color depending on the health remaining. In the combat manager, first the player and enemy positions are compared to find the difference. Then the player can attack the nearest enemy to the player, but only if it's within attack range. When the player presses the shoot button, the enemy within range takes damage. The user can log in with a form which sends the entered details to the server to check it against details in the database. Then the user can play the game as usual. After the game ends, you can then visit the dashboard. The dashboard shows your username and your highest score. If you play as a guest, aka don't sign in, then you can't access the dashboard. You get an error for unauthorized access. The user can also register a new account. Simply fill out the form with a new username and password. After creating an account, you will be directed to the login page where you can log in with the same details. Again, once you're logged in, the game starts. Visiting the dashboard before the game ends means your score isn't saved. After you complete a full game, your score will be updated. Logging in is quite straightforward. A username and password is entered into the form, then the username is passed into the SQL query to check if it's in the database. If it is in the database, then the password gets checked. The password is hashed using bcrypt, but a function allows you to compare the unhashed password with the hashed one. When the login is successful, the username gets stored in the session. The session is a continued period of interaction that a user has with a website. Storing the username in a session means that the user stays signed in throughout all pages of the website. Each session has a secret, which is a layer of security to ensure the user's data doesn't get tampered with. Registering a new account starts similar to logging in, the only difference being that the hash function is called. The server checks for whether there is an existing record with the entered username. If there isn't, the server takes a new username and hash password and inserts it into a new record. To hash passwords, I use bcrypt salt rounds. Bcrypt salt rounds tell bcrypt how many times it repeats the hashing process, therefore making passwords harder to crack. This post method saves the current score as long as the user is logged in prior to playing the game. The check game over function uses a fetch to call the save score post method and passes the score into it. When loading the dashboard page, the client sends a get method to retrieve the user's highest score if logged in. Here is a visual representation of the client-server communication. When registering a new account, the client sends a post request with a username and password. The server then hashes the password if the username is not taken, and stores it in the database. Once that is done, the server sends a login redirect to the client, and then the client gets the login page. When logging in, the client sends their username and password to the server. Then the server uses the username to find the matching hash password and compares it. If everything matches, a new session is created using the username. Then the server sends a redirect to the game. Then the client sends a GET request for the game to the server.